Hi, my name is Robert Massey. I'm one of the co-founders and CEO of Astrolabe Analytics, and today we'll be walking you through the process of getting started with our software. You can start off by visiting our website, which is astrolabe-analytics.com, and right on the front page there you'll find a call to action which will let you demo our software. So if you follow that link, it'll take you to this page. If you hit sign up, and if it's your first time, you'll be able to create a fresh, new, clean account. Once you add your information and hit sign up, you'll get a confirmation email from us letting you into the rest of the web app. Once you're in, you will be at our Projects tab, which will greet you with some of our data management tools. If this is your first time logging in, you won't see any of these data sets available, but what we can do is upload some files and get you started. So you go to Upload Files, hit Select File, drop in whichever data set you want to upload, and make sure you give it a nice descriptive name so that you know what you're uploading. Once that is done, the grayed out means that it's thinking about processing the data. The black means that you've got a project that's ready to go, and if it turns red, then that means something bad has happened. Here we see that it automatically refreshed without us having to do anything. If you get impatient and you've got a lot of data you're trying to upload, you can always hit the refresh grid to speed things up. Another important point is which type of data we're able to process right now. Presently, we can take in data from in Excel format from Arbin or Newware or Makeor or land cyclers. We can also process res files from Arbin or CSV files from Makeor, but unfortunately if there are other types of data that you're trying to process from in other formats or from other types of equipment, if you're curious if we can upload that, the unfortunate answer is no right now. But if there are other types of equipment that you're interested in working with, please reach out to us and we'll be happy to bump it up our priority list. Another convenient feature will let you upload an entire batch of data all at once. If there are a collection of different files that you'd like to upload simultaneously, you can select them all and upload them in one go. In particular, this set of data had been named such that the file name here corresponds to different pieces of metadata that are being automatically populated once you upload it here. So here we've got a silicon anode project that is going to process all 20 or so of these files. So it's thinking about it now. As we get started, it's going to take us back to the Projects tab. Here are all the grayed out tests that we uploaded. And as you can see, it's automatically refreshing as the new data gets processed and ready to analyze. Once you have a lot of data in here, it gets a little bit more complicated keeping track of everything. So we have a few different methods of querying your data and otherwise organizing it in different ways. So first of all, you can search through this and say, show me everything that's lithium cobalt oxide in here, and this search tab will give you everything where it's been tagged with lithium cobalt oxide in any of the fields here. We also have different ways of actually looking into some of the data within the projects, and we can say show me every data set where the number of cycles is greater than 100, and there you go, there's 4 of them here. What about if it was greater than 200? That would just be those two, and a handful of other different types of tools similar to that for querying the actual contents of the data that we're looking at. Now that we've plugged in some data, we can now take a look at it. There are plenty of different tools we have for visualizing and analyzing the data, but for today, we'll stick to differential capacity analysis, comparing 2 different cells, and generating templates for voltage profiles. So let's go back to the lithium cobalt oxide cell back here. Once you pick one or more cells that you'd like to look at, you can hit plot selected, and it'll take you to this page. Along the left-hand side are a bunch of standard routine charts for battery data visualization, and then along the top here are a bunch of different tools for automatically processing and formatting and otherwise configuring these plots. So this one's only got 10 cycles in it, but what we can do is, let's say dq versus dv is, here's our charge, and can enable our discharge for this for the first cycle of this lithium cobalt oxide cell. So you can see the the peaks corresponding to the electrochemical reactions of lithium cobalt oxide, but it's a little bit noisy. What we actually can do is go under here and put in an adjustable parameter, basically, where this threshold is going to perform the numerical derivative instead of every single data point like it's doing right now in the data set there. We can set that to say, okay, calculate the numerical derivative every 4 millivolts. That's an adjustable parameter. You can set it to whatever you want, but as you can see, it cleans up some of the noise in there. You can play around with that to see if you want to keep a whole bunch of the original data in there, or if you want to buff out some of the noise. You can do whatever you want with that. It's a quick and dirty way of cleaning up some of your differential capacity analysis. Another basic feature will let you compare the performance of two different cells side by side. In this case, let's look at the silicon carbide cell we put together, and let's look at the rate performance of these two tests. We've got 51 cycles apiece, and what we'd like to do is see how they compare to each other. Here we've got the charge performance for each of those two cells, and there's a bit of a discrepancy here, but also important to note that we've got different amounts of active material that we used for each of these two duplicate tests. So what we can do is normalize that by the mass, which we have saved in the metadata, and that will automatically do that calculation for you to make sure you're comparing apples to apples between the tests that you're running. If you are testing other things, you can also normalize that by the cross-sectional area of the cells, or change the units in a bunch of different ways in order to make whichever comparison is most pertinent to your situation. Alright, one of the last things we'll go over here is how to pull out voltage profiles from your cycling data. Here we'll look at the NCA file we'd uploaded earlier, and here we can see we have 306 cycles in this data set. As you can see, it's not a particularly good cell, but it is trying its best. Now from here, what we can do is say, go under the Cycle Selectors tab. We have a couple different options. We can either specify a range of cycles that we'd like to look at specifically, or pull out a cycle every certain number of intervals, or specify some custom combination of the two. For our purposes here, let's say we want to look at every 50th cycle, then hit save. Then it's going to filter that out to look at cycle 1, cycle 50, 100, so on and so forth. From here, what we can do is go to voltage versus capacity, where here we have the first charge cycle for this cell. We can also toggle these other cycles on and off to see the discharge, the 50th charge and discharge for cycle 100, and so on and so forth. So there's a pretty quick way of automatically pulling out the information you'd like to see for your voltage profiles during cycling. On top of this, you might not want to go through the hassle of doing something in 6 clicks. We can just do it in 1. We have templates that automate this down even further, where if there's something you'd like to look at over and over again, such as a voltage profile of every 50th cycle, you can create your own custom template that contains the same information that we've just gone over. So we gave it a name. You can specify capacity in this case, but you can also look at all the other different types of values to look at for the X and Y axis, capacity versus voltage, and specify the 50th cycle, or whichever other number of cycles you'd like to look at, and then a handful of other optional settings that you can plug in there and hit save and automatically apply. So here we have applied the voltage profile. It does the exact same thing. It's pulling out the cycling information for these particular cycles. Alright, the very last thing I'd like to show is exporting your data back into Excel once you have it in a shape where you'd like to work it up in some other piece of software. So what's going to happen is, once you have your figure exactly how you want it, you can go in here and hit Export Filtered to Excel. What's going to happen is it's going to download this information. You're going to get an image of this exact chart plus the data that comprises the chart. So let's open this file here, inside, you're going to see here is the chart we just generated, and on this next tab here is the data comprising it. So here we've got the capacity, our x-axis. In the header here we've got the horrible, obnoxious name that I gave these files. But as you can see, we've got the voltage for the charge cycle, the first charge cycle here, the first discharge cycle here, then the charge and discharge for cycle 50, voltage for charge and discharge cycle 100, and so on and so forth. And with that, hopeful that that is a good start to get you up and running using our software. We hope it serves you well. And if there are any bugs or additional issues that you'd like to cover, please feel free to reach out and we'll be happy to speak with you. Thanks.